Yes, there we go. If you don't mind, Austin, go ahead. Brother, thank you. How we doing? Holy. Look at the mouse. Look at the pie charts down here. Look freaking awesome. We're up to about 20,000 trials. Yay, us. 20,000 trials. Ha! Look at the percentages.
About right.
About right, exactly. They're not perfect. If you look up at the 7 is definitely the most frequent. And they're not perfect. 6 and 8 should be exactly the same. They're not, but they're correct to 2 decimals, which is all we're going to worry about anyway in here. And when you actually round off the 2 decimals, look at that distribution. It's freaking beautiful. 17%, 14%, 11%, 8%, 6, 3. Notice. Less than 5%. Less than 5%. Something just fluttered. I saw it, didn't it? I think one of the decimals just fluttered and fluttered back. Because these won't stabilize perfectly, ever, because they have to go off to infinity. And infinity is full of little goofy things like 5 boxcars in a row. I would love to be able to record this entire thing and then go through, we should have time to do this, and then go through it and find the time when you saw like snake eyes 12 times in a row, because you know it's going to happen somewhere. It's called the infinite monkeys theorem. Have you ever heard that? Did I mention this in class before, the infinite monkeys theorem? You put an infinite number of monkeys in a room, give each one a typewriter, let them pound away on it. You are guaranteed, after infinite time, to have the complete works of William Shakespeare. Randomly. That's the infinite monkeys theorem. Think about it.
Is that in writing, like print somewhere?
You can't prove it.
Publish that?
No. Well, yes, if you count Wikipedia as a published source. But no, it's been around for decades. The infinite monkeys theorem. Eventually, it's wrapped up. It's wrapped up in the phrase, "Even a blind squirrel gets a nut sometimes." You might have heard that one before. My buddy Derek just completed his rock climbing project at Smith, and I was congratulating him. I'm like, "Dude, you're the man." He's like, "Hey, a blind squirrel gets a nut," meaning that even if he couldn't climb and he threw himself out of a rock climbing up, eventually he'd get up it. Not exactly true. Gravity still wins. But the idea is, if those monkeys are allowed to explore every permutation of the keys, eventually one of them will be the entire complete works of William Shakespeare. And that is true. That is exactly true. Also, there are also quite a bit of them that are the exact works of William Shakespeare with one number or one letter wrong. There's even more of those, aren't there? I mean, wherefore art thou Romy? Right? Think about that. How many of those are there? Romy 2. Oh yes, there it is, infinite monkeys. So that's what we're seeing, essentially. Somewhere in there, we're going to see a whole bunch of boxcars in a row. We're just probably not going to be looking at it when it happens, just like we're not going to be sitting there with the little old lady from Pasadena. It's jackpot on the one-armed bandit, so don't bother waiting for it. Better off to play the $5 slots, get the free drinks. Or not. Maybe you'll change your mind on that later, too, after we talk about how much you're actually going to lose on average over time. Fair, good, believable. There's a lot of information all at once. I apologize.
I was thinking about Vegas.
Think about Vegas. Good. Keep thinking about Vegas and see how it applies to all of this. Now you know how 2 dice behave, yes? Now you know how 2 dice behave. Now you can actually analyze games like craps if you haven't already done so. It's a very, very fun game. And analyze how you're always going to lose on average when you play craps. We'll come back to that one. That might be the last exam, too. Say that again.
I didn't say it.
Oh, sorry, Laura, go ahead.
Figures are positive.
Well, no, I'm realistic.
I know.
On average, you will lose money playing craps.
Yeah.
Yeah, if you play long enough.
Somebody
It's called the Gambler's Ruin. Here's another one you can think of. Here's the Gambler's Ruin. You ready? Imagine a game has a 50-50 payout, or 50-50 odds, which craps is close. Craps is close, but it's not perfect. It's just slightly edged against you by the house. But let's pretend it's 50-50 for mathematical ease of computation. You walk up and bet $1. If you flip heads, you win. If you flip tails, you lose. Fair so far? Okay, so you slap $1 down. Slap $1 down. And you flip. If you win heads, suppose it pays 2 to 1, they give you $2. You walk away with $1, you have profited $1, or 100%. Excellent. Excellent. But let's suppose you don't. Let's suppose you flip tails. Do you go home? If you're smart, yes. If you're not smart, you now bet $2. Now you're $3 in the hole, right? But if you flip heads on the next flip, you'll win 4, which offsets $3 that you lost and clears your 1. So you've won $1, yes? That's if you flip heads the second time, after flipping tails the first time. But suppose you don't. Now you bet $4. Now you're $7 in the hole. But if you flip heads, you'll win 8. Maya's laughing. But I'm winning $1 eventually, yes? The kicker is, what is eventually? That's an awful lot of work to win $1, isn't it?
Yeah.
That's the gambler's ruin. That's why people don't understand Vegas. There is a reason why a city buried in the desert, has its lights on all the time, and a fountain in front of the Bellagio, in basically a 5% humidity environment. Where's that water come from? Los Angeles. Right? They're pumping that water in off the Colorado and from Los Angeles. There's a rock climb in Owens River Gorge called Flush Twice, Vegas Needs the Water. Right? There's a reason that city exists. There's a reason it can pay for all that stuff. There's an old cartoon I saw, Welcome to Glamorous Las Vegas, generously paid for by people who are bad at math. Right? I don't know how much of it's bad at math or just delayed reality, suspended reality, but we're not going to have a good time in Vegas. And I'm not saying don't. I'm just saying be comfortable with the fact that you're going to lose money. If you can come to peace with that and reel yourself in over time, you'll have a great time in Vegas. Speaking of Vegas, everybody cool with this? See what's going on? Okay, good. Let's do a third experiment. You have a coin in front of you, yes? Let's model the gambler's ruin. Let's model the gambler's ruin. Model the gambler's ruin. So, what I want you to do is, and I want to make sure I say this right. I think I confused the hell of the last class.